Assignment 1 by Rahul Madan. And this is the visual representation of the implementation of the agent. Here you can select the problem type, easy, medium, hard, and algorithm. So let's say easy for all of them, I can do together. These are the stats and these are the steps involved for each one of them. Same for medium, I can do all. This also gives you stats and the steps involved in each one of them. And then this is for hard, and let's say I do best first. Hard, everything together takes a bit of time, so I'm doing it individually. This is the best first, and then going to BFS. It is it takes a couple of seconds to run, but gives result. Uh, so should be here. Yeah, so hard, BFS, and these are the steps. Okay, so moving on to the implementation code piece. So this is by Flask implementation. This one takes the algorithms list, and then these for all I call one by one each one of them, and for else I call individually. Create an instance of the agent and call the solve puzzle function. This is my node class, and which has all the initial states of the node, state, depth, cost, action, heuristic functions. These are heuristic functions implementation. If I go to the successor function, this is called by the main class. What I'm doing is I'm trying to go to each direction and get a valid child. If child is valid, I add it to the list and return back. A little bit about the successor function. This one has validation. It doesn't go out of 9 by 9 matrix and then create the cost associated and the state associated by just moving things around and then create a node for that. And going to the main class, if I look at the solve puzzle function, it has hard-coded easy, medium, hard, and then it creates a node for the input state, validate if it is there, and add it to the queue. So this is a common code which was in all algorithms, so I moved it out. Otherwise, just call whichever algorithm it is. Some algorithms require it in the explode state initially, so I add it here, otherwise others don't. So quickly going through each function. So this is the breadth first. I look through the queue, space cost, max of the current value and the current length of the queue, pop the 0, and anytime you pop, you add to the time cost. Then going through the queue, I expand child. This function returns the successor function, returns a child. If child matches the goal, child. Otherwise, just validate that if you have explode, since explode is a dictionary, I can easily validate if it is already there. If not, add it to the queue and add it to the explode. Same goes for DFS. It's just that this one is LIFO and that one was FIFO. So I'm doing insert at the 0 place, and then this is the yeah, I'm popping it from the first place. Same is for ID, iterative deepening. I reset all the variables and then call with the depth value. And in depth, I go around. If the depth is reached, I go around with other nodes and just, yeah, so that it doesn't go beyond this depth. So this one is uniform cost, where I'm doing the sorting based on the path cost. Checking if so explode is here, and then the part where I'm checking duplicate in the frontier queue is I've created for these particular algorithm, I've created another dictionary which takes care of the frontier node dictionary, and anytime I add it to the frontier, I add to that dictionary as well. If the cost, because I'm adding the cost as a value to the key, so I'm validating that if that is greater, that means we have to add this child, otherwise there is no else to this, so I don't ignore the child if it has lower value. Then going to best piece and AH1 and AH2, same thing, based on H12 and H1 I'm sorting it at the end. Same logic for duplication here and same logic for explode keys here. Thank you.